Hello guys, welcome back to Maison African Motives. Still working on mathematics for grade 11, working on functions. We've got the question paper that we're going to be focusing on question number 6. That is the question paper of November 2019. From the question 6 that we are given that the diagram below shows the graphs of f of x and gx, in this case, f of x, which is a quadratic function, that is a parabola, and we are given gx, which is a linear function, minus 3x plus k. The graph f casts the x-axis at point A and B, and we are given the y-axis at C, and also here's a turning point at point D. Graph G casts the x-axis at B and the y-axis at point C. E is a point on G such that DE is parallel to the y-axis. So take note here, we are given that DE is parallel to the y-axis. This is very, very important to note that the x values throughout this D are the same. So if you have your value for x throughout, it is the same, the value of x that you're going to have. So that is the condition for a parallel line. If it is parallel to the x-axis, that is going to be x values are the same throughout. Okay, so you shall see that one later on. Okay, the first part of the question on 6.1 was to show that k is equal to 15 from the information that you are given. We are supposed to use it and show that k is equal to 15. All right. So where do we have k? If you have to take note, our k is taken from the g of x. That's where we have our k in this case. All right. So I'm going to take from the g of x here. Let me just write it aside. So that's 6.1. So from g of x, we are given our equation as negative 3x plus k. So k here representing the y-intercept, which is the y value that you can obtain by substituting any point that you're given, as long it is on line BC. All right. So from the line BC, we are given the point B, which is at 5, 0. So you can take the point B, which is at 5, 0. Got the point X. We've got the value Y here. So you can substitute. That's GX is equal to minus 3K, minus 3X plus K simply means y is equal to minus 3x plus k. That's what it simply means. So meaning to say we can substitute the value of y here, which is a 0. And in place of x, we substitute a 5. So this is going to give us negative 3 times x, which is 5, plus k, like this. So you can determine the value of k. So that's 0 is equal to negative 3. And 5, that's a negative 15 plus k. So we can transpose 15 to the other side so that it can be a positive. So that's 0 plus 15 is equal to k, which is a 15. 0 plus 15, that's a 15. So as you can see, our k is equal to 15, which is the part that we are being asked to show. Okay, from the other part, now we are given to determine on 6.2 the coordinates of D, that is the turning point of F. All right, so D, that is our turning point of F here. That is where we have our point D. Okay, here, take note, that is where we have our D. So we can actually determine this using two ways. Okay, if you take note here, D is actually the value of x at D here, the value of x, which is at the x of symmetry, of the line of symmetry, is the average value of point, the value of x at point A to the point at B is the average point. So meaning to say we can calculate this using this consideration or using this option 6.2. So we can have the x at the point D by having an average of the x at the point A plus the x at the point B, everything over 2. So this can actually give us the value of x at the point D, which is at the turning point. So we can take advantage of that because we are given the solutions. So that's the x at point D is equal to x at point A, which is minus 3. Remember, this is xy. So x is minus 3. So it could not be minus 3 plus the x at B, our x at B, which is a positive 5. So this is over 2. So you're going to have the x value at point E. All right, so this is going to be a positive 1. Okay, so that's a positive 1. So we've got the x value at point D. We can have the value of y. Or we can use the idea, most of us, that we apply, which is from the function that you're given of f of x. That is our f of x here. we have got our f of x given as negative x squared. So take note, our f of x is given as negative x squared plus 2x plus 5. So the value of x at the turning point is taken from the formula minus b over 2a. So that is, remember, we have this from ax squared plus bx plus c. So the a corresponds to -1, the b corresponds to +2. That is how you take this formula. So that means x is equal to minus the value of b, which corresponds to +2. So that's a -2 over 2 times a. Our a here corresponds with -1. So that's 2 times -1. So you can obtain the value of x, which is the same as the one that we got before, which is the x at point D is a 1. So having the point of a, having the value of x, you can have this either from either way. You can use this part or you can use this part, okay? Or you can even apply so many ways, only that we are limited to the derivatives now. Okay, so with this value of x now, we can determine the value of y by substituting into the original function, which is our f of x. So this is going to give us the value of y. So that means the y value is going to be, if we substitute here, this is going to be -1 squared plus 2 into 1, that is plus 5. So you substitute in place of x, you are substituting 1. So this is going to give us the value of y, which is 16. So thus the point D here is the value of x, which is 1, and the value of y, which is 16. Remember, this gives us a point. So that is going to be our point D in this case. So using that information that I was talking about, we have the x value at point D, which is 1, meaning to say at this point D throughout, or from the point D throughout, because we are given that this is a vertical line. So throughout this point from D, throughout the line from D to E up to them, x-axis throughout this, it means our x is equal to 1. So which means we've got the equation of this line throughout. We know that x is equal to 1. Okay, here I'm just saying maybe we might need this information later on because of the parallels. Okay, so this we might need this later on. Okay, let's check the other part of the question. We are given on 6.3 to determine the values of x where f is increasing. Where are we having our f increasing from? So if you are to check from your graph here, we can see that our f is increasing from this part. If you are to check properly, our x is actually increasing from values, which is the any value of x that you're going to have from as long these values are at this side. So you can have actually up to -infinity. These are endless values when it is starting to increase. Remember, to increase, that is going up. So it is going up from these values up to from -infinity actually. So it will be going up, it will be going up, it will be going up to the point where it reaches the turning point at this point. That is when now it is stationary. So at this point D, there is no movement at all. It is stationary at point where x is equal to 1. It is now stationary, meaning to say there's no movement. From this point D, if you check now, it's now decreasing. Our function is going down. It's now decreasing. So as we are focusing with these values of x, which are of this side of 1, from this side, not at x is equal to 1, because at exactly where x is equal to 1, there is no movement. It is stationary. So we are referring to these values, which means we are referring to the values such as 0, -1, -2, -3, -4. So these values, if we compare them with x, what can we say about these values compared to this x, which is equal to 1? We can see that these values, they are less than 1. We are talking about 0. We are talking about -1, -2, -3, up to infinity. All these values, they are less than 1. So meaning to say here, we can conclude that where our function is increasing is for the values of x which are less than a 1 at the turning point. So this is for all the values of x, meaning to say up to negative infinity, everything is included from this part. Or we can present this, since we are saying it's from negative infinity, limited to positive 1. So this is going to be limited up to 1. So these are the values of x that you're going to have limited 1 if you are to indicate this. So this you can just see it from the graph. Okay, so that is just 1 mark there. 6.4, we are now given to calculate the average gradient between the point A and D. What is the average gradient? Remember, average gradient, you need to find exactly the point that is at A and exactly the point at D. Then you use the gradient formula. All right, so let's check what we have at A and at D. Okay, let me just remove some of this part here. Okay, so here, remember that at D, what we know is that x at this point is equal to 1, and we calculated the point D before from this point here, where we use this concept. So D is at 116. So this point is at 116. Okay, so meaning to say with the point D and the point A, we can calculate the average gradient. Okay, so let me just write our formula down for the average gradient. Remember that the average gradient, just like a normal gradient, it is equivalent to the change in y over the change in x. All right, so this is 6.4. So our average gradient in this case is the change in y over the change in x, y2 minus y1 over x2 minus x1. So we are simply referring to the points. You can just say this is your x1, this is your y1, this is your x2, this is your y2, just this the way that you want. Okay, that's y2 minus y1, which is 16 minus 0. So this is going to be 16 minus 0 over x2 minus x1. So x2, that's a 1. So that's 1 minus x1. Our x1 in this case is a negative 3. So that's a negative and a negative. So that's going to be 16 over positive 4, which is going to be a positive 4. So this is the gradient that we are going to obtain as the average gradient of AD in this case. All right, so that is how we can apply, just same way you use to calculate the gradient. All right, then we move on to question 6.5, where we now calculate the length of DE. So that is the length of the line DE, and we've got 2 marks for that. Okay, I referred this in another question paper where I was saying that if you are, okay, let's check from the diagram first before I say this. If you check from D to A, this is from a vertical line. Remember, we are told that this is parallel. So if this is a vertical line, it means that for you to obtain the distance, you can simply apply the concept or the y values here. Okay, let me write this part here. I talked about this in another paper, but it was for the horizontal part, but this time it's for the vertical. So it simply means that the distance DE is, since it's a vertical line, we are talking about the y values. So we are going to work with the y value at D minus the y value at E. That is what we are simply saying. Or you can use the distance formula. I'm going to make it use the distance formula again so that we confirm that this is just one and the same. So we have the y value at point D is 16. This is the point D. The y value is 16. But we do not have the y value at point E. So where can we obtain this y value from? Where can we obtain this? Okay, take note, E lies on the line BC. And before we were given the line BC, which is our GX in this case. This is GX, a line BC, where we are given that GX is equivalent to minus 3x plus k. And we calculated the value of k in this case, and we got a 15. So meaning to say our GX in this case is supposed to be written as minus 3x plus the k that we got, which is 15. So from this, we can obtain the point E because it lies on G. And where it lies on G, it lies at a condition where X is at 1, because we have said this is a vertical line. So at this point, X is equal to 1. So that means we can obtain the value of Y if we substitute our X, which is 1, into the equation of GX. All right, so if we do this, we are going to obtain the value of y in this case, that is at point, okay, this is a 15. So this is going to be y is equal to -3 plus 15, which is 12. So we've got the value of y in this case, which is 12. So, or we are having the point E, which is 12 like this. So as we can see, the values of x are the same. That means this is truly a vertical line that you're having. So you simply subtract the y values. The y value here at point E is 12. This is your x and this is your y. So what I'm simply saying is that the distance that you're going to obtain here, you subtract, that is the y value at D, which is 16, minus the y value at E, which is 12. So if you subtract this, we are going to obtain 4 units in this case. All right. Or maybe you want to use the distance formula. It's still one and the same thing. We are going to obtain the same answer. So in this case, what you're going to do for the distance formula, you're going to take the point D and the point A. Remember that our distance formula, it states that DE is going to be equal to the square root of x2 minus x1 squared. That's plus y2 minus y1 squared. So we can use the distance formula to calculate DE, which is going to be the square root of x2 minus x1. We can just take this to be our x1 and this our y1 like this. So x2 minus x1, that's 1 minus 1. x2 is 1, x1 is 1. So this is going to be 1 minus 1 squared plus y2 minus y1. So y2 is 16, y1 is 12. So this is going to be 16 minus 12 squared. All right, so this is going to give us the distance DE, or the length of DE in this case, which is the same. That is going to be 4 units in this case. Okay, so this is how we can use the distance formula to determine the length, or we can simply have this. If it is a condition that you are given a vertical line, that is what you can use. If it is a horizontal line, you subtract the x values in that horizontal line that you're given. Okay, so that is how you can determine your length or the distance. All right, if you check on question 6.6, we are given that hx is another function which is equal to f of x minus 1 minus f of x minus 1 minus 2. Determine the equation of hx in this format. All right, what are we actually given in this case? Okay, so I'm going to have our format in this case, our hx, and let me just write where we can properly see this. Okay, we can even remove this part. Okay, this is not important for now, so let me just remove it for now. Okay, remember that before we were given our f of x, so this is a 6.6. Okay, before we were given our f of x, so we're going to work from there. Our f of x, we are given before this as negative x squared plus 2x plus 15. Now we are given another function that is related to this f of x, but now it is given as hx, which is f of x minus 1 minus 2. Okay, so this is the function that we are supposed to determine from the f of x that we have. We are supposed to have another function of hx, which we are given as f of x minus 1 minus 2. So the first thing is, what does this part mean? What does this part? It means that in place of x, we are going to substitute x minus 1. Then after finding everything, we are going to subtract minus 2 from the function that we are going to obtain. So it simply means here we are going to have our hx, which is equal to, in place of x, we are going to substitute x minus here. This is where we have our f of x. So in place of x here, we substitute x minus 1. In place of x, we substitute x minus 1. So this is going to be negative. That's x minus 1 squared. In place of x here, so this is plus 2 into x minus 1 plus 15 like this. So this is your hx. But in this case, we are supposed to take note that after substituting the minus 1, there is a negative 2 that is affecting all values of y. So this is going to be subtracted. as it is. Okay, this is the presentation that we were supposed to have for for hx, but now we are told that we are supposed to have our hx in this format where hx is equal to a into x plus p squared plus q. What type of format is this? Where do we apply, or where do we get this format from? Okay, let's see. This is our part, guys. We are supposed to have our hx. We are told that our hx in this case is supposed to be in the form of a into x plus p squared plus q. This is a format that is taken from completing of the square method. So from completing of the square method. Completing of the square method. All right. This is where we took this format from. So meaning to say, we are supposed to simplify properly everything, our quadratic expression, then we complete the square from there. That is what they are saying here. Okay, so let's see how we are going to obtain these, guys. Okay, so remember the format. So the first thing, we can expand our brackets. In this case, hx is going to be minus. If we expand x minus 1, remember, this is taken from a minus b squared, which is equal to a squared minus 2ab plus b squared, or you can expand the brackets of x minus 1 into x minus 1 properly. That is going to give us x squared minus 2x plus 1. All right, we move on to the 2 here. It's going to expand everything. That's 2 times x, which is going to be 2x, 2 and negative 1, that's negative 2, plus 15 minus 2. In this case, you can simplify 15 minus 3, 15 minus 2, which is going to be 13, or you can just leave it like that, whatever that you are comfortable with. Okay, expand the brackets by negative part here. We are going to obtain negative x squared, negative and negative, that's a positive 2x, negative and a positive, this is going to be negative 1, plus 2x minus 2 plus 15, and we've got negative 2. So what you're going to do is to simply collect all the like terms. We've got negative x squared. In this case, we move to the part that is got x. So here we've got 2x, and here we've got 2x. So if we add 2x and 2x, this is going to give us a positive 4x. Then we move on to the numbers. We've got negative 1, negative 2, plus 15, negative 2. So you simplify this direct from your calculator. This is going to give us a positive 10. All right. If we were not told actually about this format, guys, to be honest, we were supposed to leave our answer at this stage. In this, we are done. But now, because of this format that we are given to leave our answer as, which is this format, we are now limited to expand further, to work out further until we obtain such type of an expression, which I said it is obtained from completing of the square method. So here we are going to complete the square. All right, so let's complete our square from hx here. So how do we complete the square in this case? Remember, we work with the x part here. We work with the coefficient of x. So you're going to obtain half the coefficient of x. But what we need first is to make sure that the coefficient of x squared is a positive. Okay, so this is the first thing that you're supposed to consider before anything. Okay, so let me just rewrite my hx. So my hx can be written as, if I factor out a negative, this is going to be negative into x squared, positive and negative, that's a negative 4x. If you divide positive divide by a negative, that's a negative 10. So if the coefficient of x squared is a positive, then we are going to find this, and it must be a positive 1, not positive 2, not positive 3. If it was a 2x squared like this, you factor out 2, so that you remain with positive x squared, not any other term. All right, so here we have got the coefficient of x. You find half the coefficient of x. Our coefficient of x here is negative 4. So you find half of the coefficient of x and square that coefficient. So this is going to be negative 2 squared, which is negative 2 squared is 4. So this term here is obtained from -2 squared, you must remember where you obtained this for, because this is going to affect our answer. Okay, so on your hx, you add the term, you add the constant and subtract so that you neutralize your question to where it was. So we are going to add the constant 4 and we subtract 4 from there. This does not make sense at all to say, why are we adding and subtracting? The purpose is to make sure that we are having this original equation. We do not lose our values. We still maintain our original values as they were. So here we are going now to complete, we have completed our square, but we are going to factorize this part, the x squared minus 4x up to 4. This is the part that you're going to work with. But don't stress much to say, how am I going to factorize this? You take this part that has got x. Okay, let me explain as I'm writing. You take this part that has got x squared, the first term, and the last term. This part that has got a square, that is x. This 4, before you expand, before you simplify it to obtain a 4, it was -2 squared. It was -2 squared. So we take this part that is being squared, the -2. Just like on x, we took x. So here we are going to take x. So this is going to be -2 like this. Then we square everything. So we have factorized. We work with the first term and the last term. Before we simplified to 4, it was -2 squared. So this is the one that you take, okay? So please take note about that. Okay, so I think this I must explain it on a separate topic so that we must understand. Yes, just a revision so that we do not waste much time. So -4 and -10, this is going to be -14. So we can expand everything by a negative times the first bracket. So this is going to be negative into x minus 2 squared. The negative has no power to multiply anything inside the bracket. So you just write it outside of the bracket like that. So it's negative here times a negative at 14. This is going to be a positive 14. So take note, the negative multiplies the first term. The negative also multiplies the second term. So this is negative, and this will be a positive. So this is our hx in the format that we are given here. Hx is supposed to be in the form a into x plus p squared plus q. So this is what they were trying to say. So this is what we have, as we can see, our format here. So that is how we can express our hx in that format. Okay, that was given as hx is equal to a into x plus p squared plus q. So this is what we have, where this point at point p at point minus qp, it represents the turning point for that function. Okay, this is another part we are not given, but if let's say they were talking about that, then we are going to apply that concept. Okay, so that was our question, guys. It was actually a tiresome question, I understand, but we are supposed to understand this part. Okay, in your revisions, you are supposed also to know how to apply or to use completing of the square method. All right, we move on to the other part of the question, which is on question 6.7. We are now given to determine the maximum value of px, which is another function again that we are given from the same f of x that we had, which is now given as f of x minus 12. Okay, this is our px. Find the maximum value of that. Okay, so how can we determine the maximum value of px from the f of x that we are given here? Okay, let me just try to explain from this part so that I do not run away from these values. Let me just use this space here. Okay, take note, guys. We are given another function. Okay, so this is 6.7, which is referred to as px, which is 3 to the exponent of f of x minus 12. So here we are asked to determine the maximum value. Okay, so the maximum value is going to, okay, because here if you are to check, we have got f of x. This f of x represents the value of y. And this minus 12 also is affecting the value of y. So meaning to say, before we had the maximum value, for f of x, if you check here or on our original f of x here, this is our f. at the turning point, that's where we have the maximum value. So our maximum value is at the point where y is equal to 16. Remember, we take the y value. So our maximum value is at 16. This is what we have. For f of x, our maximum value was at 16. Now we are saying we are subtracting a 12. That is a difference that we are having. So meaning to say, for f of x minus 12, we are going to obtain the 16, which was the maximum value before, minus the 12, the corresponding value of y, which is going to occur at 4. So we are saying that for this function, our maximum value is going to occur at 3 to the exponent of 4, the value of y that you are having. And 3 to the exponent of 4 is going to give us 81. That's how we are going to obtain our maximum value in this case. All right, so just a tricky question, but just direct if you understand the concept of maximum values and so forth. Okay, then on 6.8, we are now given a condition here to state the values of x for which f of x plus k plus 0 is equal to 0. We have two distinct real roots. Here we are talking about the values of x. And this is a function of f of a. Remember, our f of x is a quadratic function, which was given by negative x squared. So this is negative x squared plus 2x plus 15. So from our quadratic function, we know that for us to have two distinct roots, we must have our discriminant being greater than or equal to 0. Therefore, we are going to be having two distinct, it must be actually greater than, let's just have greater than 0 in this case. But if we are to add a k, does it affect our values of x? Because k is a constant. So this is not going to affect anything because we are referring to the values of x. If it was for the values of k, therefore we work for the values of k. But here we are saying for the values of x. So x is not going to be affected. So we are going to work with all the values of x, which are the real terms, which are part of what? Which are part of this equation that you're going to have, but limited only at a condition that our x values will be at the what? At the turning point where x is equal to what? Where x is equal to 1. Okay, so this is how we can attempt these typical questions, guys. As you can see, we just have to try to work out with more question papers as we revise towards the exams which are ahead of time. But for now, that's it, guys, from Maison African Motives. Till we meet again.